So hi guys, welcome back. So here we've been again. We have a sample problem on a Rayleigh's method. So find an expression for a drag force on a smooth sphere of a diameter d, moving with a uniform velocity v in a fluid of density rho and a dynamic viscosity mu. So take an example that you have a cricket ball, right? So when you're going to throw the cricket ball, so what will be the drag force? So drag is opposing force. So when you throw the cricket ball, what happens? Some force will be opposing your the ball. So those forces are depends on. So these forces which depends on the diameter of the ball. If the diameter of the ball is small, then the drag force will be small. So say for example, if you have a football, the drag force will be much more higher than drag force compared to the cricket ball because the diameter is very higher. So on moving with the velocity, so if the speed of the ball is high, probably the drag force will also be high because it's opposing. So in a fluid of density rho, so if it moves in the air, it can go at the highest. The drag force will be, low. Okay, so for the same example, if you throw the ball under the water, the density of water is much higher compared to the density of the air, so it doesn't move the distance covered by the cricket ball in the air, and water will not be the same. And dynamic viscosity, again, the viscosity of air will be less compared to the viscosity of water. Okay, so here we're going to find an expression for this using the Rayleigh's method. So the drag force F is a function of diameter, velocity, density and dynamic viscosity. So drag force F equals to K into d power A, V power B, rho power C, U power T. So that's how we write an equation. So dependent variable which will be equal to the function of independent variables power arbitrary constants. Okay, K is the non-dimensional factor, so substituting the dimension on both sides. So these dimensions are already we have discussed. So for force, for diameter, force will be Newton, so ml t power minus 2, diameter length L, velocity meter per second, so L t power minus 1, rho is kilogram per meter cube, so mass kilometer cube, so L power minus 3, so per meter cube, so denominator to numerator minus 3, so mu will be equal to Newton second per meter square. So again if you substitute, Newton second per meter, m L power minus 1, t power minus 1, so these are derived quantities. Okay, so now what we're going to do is equating the powers of m, L, t on both sides of the equation. So the powers on m is 1, so 1 will be equal to, on the other side, m power c, so c plus m power d, so plus t, so 1 equal to c plus t. So equating powers of L, so L power 1, so 1, L power A, so A plus L power B, B, L power minus 3C, so minus 3C, L power minus 1 into D, so minus T. 1 will be equal to A plus B minus 3C minus T. Equating the powers of T, so minus 2 on the left hand side equals to minus B minus T. So now we have 4 unknowns. So A, B, C and D, these are 4 unknowns, but equations are only 3. Okay, so it means that the fourth unknown should be in all the equations. So that should be very clear. You have to be in keep it in mind. So this is the most important condition. So if you have any equation, right, so there are 4 unknowns, A, B, C, D are the 4 unknowns. So A, B, C will be in terms of D, the fourth unknown. So that's what it says. These are 4 unknowns, but equations are 3. Hence, it is not possible to find the values of A, B, C, and D. But 3 of them can be expressed in the terms of fourth variable. A in terms of D, B in terms of D, C in terms of D. Okay, so or else we can go with B in terms of A, C in terms of A, D in terms of A. Okay, so three equations should have the fourth variable, so that is very important. Keep it in mind. So now what we're going to do is we have C from power of m, so C will be equal to 1 minus t, so take it to the other side. Again B will be equal to 2 minus t, so we're going to take this t other side, so plus, so minus we taken outside, b plus t, so b will be equal to 2 minus t. A will be equal to, so A will be equal to 1 minus b plus 3c plus t. So now we know the value of b and c, substitute the value of b and c here. So that is equal to 1 minus, so b equal to 2 minus t, so 2 minus t, so it's again here minus, so minus of 2 into minus of minus t, so becomes plus t, so 1 minus 2 plus t plus c, so here it's minus c, right, so minus c, so again it goes to plus c, so plus 3c, c will be equal to 1 minus t, so 3 into 1 minus t plus t, so if we simplify it, so this will be equal to, c will be equal to 2 minus t. So now you can be clear that a in terms of d, b in terms of d, c in terms of d. So c equal to 1 minus t, b equal to 2 minus t, a equals to 2 minus t. Okay, so now we're going to substitute the values of a, b, c in this equation 1 number 1. So here we're going to substitute. So if we substitute f equal to k power k into d power a, for a we know 2 minus t, 2 minus t, b power b, so b equal to 2 minus t, so b value 2 minus d, c power in terms of rho power c, so c will be 1 minus t, and mu power t, so mu d value, so if you not got anything, so the substitute the same value t. So simplifying this, we will take the numerator to the one side and the powers with the alphabets to the other side. So f will be equal to k into d power 2, v power 2, rho power 1. So into d power minus t, v power minus t, rho power minus t into mu power t. So this will be equal to k into rho d square v square into, so this everything in terms of d, am I right? So d power minus t, v power minus t, rho power minus t, mu power t. So positive signs of a power will be on the numerator, negative sign indicates it will be on the denominator. So mu by rho vd whole power d. To take this arbitrary constant, we introduce the function. So f will be equal to k into rho d square v square function of mu rho vd. So this is an expression to find the drag force on a spherical ball, on a smooth spherical surface. So if the diameter known, density known, velocity known, dynamic viscosity is known, substitute the values and whatever the answer will be equal to the drag force. So hope you guys got some clear idea. So thank you guys.